anything, you had to call a function. Everything was a function in this language, right? So the paradigm was call a function, which calls another, which calls another. And we get things done by passing data around and having a few side effects here and there. And then in 1958 and 59, we get Flowmatic and COBOL with Grace Hopper developing these ideas as COBOL. And the target audience was programmers, but also administrators and accountants, people who weren't comfortable with functions. And so the language ended up looking more like English. And guess what? No functions at all. So there's the start of it. And for many years, the state of programming languages was like this. If this is the world of programming languages, Lisp was on one side, being the functional language. COBOL and all the other languages ended up being procedural. And of all the languages on the procedural side, COBOL was, in some sense, the most procedural because it had no functions at all. So how did COBOL get away with that? How do you get away without functions? Well, they decided to go this way. We'll have global data. We'll make a very simple organization. If you declare a variable, you can see it everywhere. Even an accountant could understand that, right? If they see a variable in a program, that variable is available to you everywhere. So global data. The main organizing principle ended up being paragraphs, right? Programs end up being sections and paragraphs and sentences. And the sentences are phrases and words. It's organized like a book. So again, an accountant could be comfortable sort of reading a COBOL program. And that's how they got away with it. How'd that work out? Great. The world's largest businesses run on COBOL. This has been a very successful strategy using global data where I can see every variable everywhere. If I'm a programmer, it sort of makes my life simple, right? I don't have to worry about getting access to the data. If I see it, I have it. I don't have to pass parameters. That makes it sort of efficient in some ways, right? I don't have to pass parameters around. It's completely procedural. And it's easy to add more code. I can just start writing another paragraph. Well, every decision has a flip side, and the flip side is if it's easy to add code, I end up with these, especially for programs that live 20, 30, 40 years, I end up with monolithic programs that are these huge beasts. And some programs have gotten so large it's difficult to understand what they're doing. And one person might take months to figure out what a program is doing. And the other flip side of this is that if a variable goes bad, since everything's global, I have to look sort of everywhere to figure out where it went bad. Another downside to that is if I want to reuse my code, I have to copy it. There may be a collection of paragraphs I could use, so I copy and paste. But what I'm not copying and pasting is the context surrounding all those paragraphs that make the paragraphs I want work in my new program. So I'm faced, if I can copy and paste, but I'm faced with having to test and debug again. And then when I think about things, if I'm writing a program, when I finish writing the code, I think I'm about halfway through. The rest of it's testing and debugging. So that's a significant part of the process. 60 years later, functions are still a winning idea. Most modern languages, even those that don't start out as functional languages, have functions, right? I can't think of another language. There may be some, but I can't think of one off the top of my head that doesn't have functions. And in fact, a lot of languages are moving toward the side that Lisp was on. They're trying to introduce functional programming ideas, not just the idea of a function, but actual functional programming ideas. And we've run into Scala, which was designed from scratch to be hybrid. It was designed to be both procedural and function. The interesting thing is COBOL is also a hybrid. COBOL, the press has this idea that COBOL is old, which is true, but it's also new, very new. And so COBOL is also a hybrid like Scala. In this case, it's procedural and object-oriented. So if I'm a programmer wanting to design functions, what can I do now if I'm working in enterprise COBOL? One alternative is the language environment. There's something called a language environment that provides many functions to us that we can use. Just to give you an idea of what this is, we're not going into it in much detail, but basically the language environment is a runtime environment for a variety of languages like C and C++, Fortran, PL1, Java, COBOL. They all run in the language environment. And within this runtime, there are functions available to all of these languages. These are not the functions we're going to talk about today. So I'm trying to put this in a little perspective. There are functions that exist in the language environment that all of these languages can use. But the functions we're talking about today exist here within COBOL. So what can we do now? Well, we can use what are called intrinsic functions. Enterprise COBOL still does not permit user-defined functions, but has plans to add them. Tom Ross was nice enough to correspond with me on this point and remind me that the COBOL standards, the COBOL 14, which defines what COBOL can be, actually allows for user-defined functions. But the actual implementation in enterprise COBOL currently doesn't have it, but there are plans to add this as a feature. Give you a little teaser here. There is a workaround that I want to suggest that you might not think about immediately for writing your own functions. We can't actually do that, but we can get close. And as a teaser, I'll mention, we'll get back to this right at the end of this talk. So for the moment, what we can do are use the intrinsic functions. Those are the built-in ones that COBOL has, and they can do all sorts of things, mathematical, character, and logical operations. And what functions do is allow you to reference a value that's going to be computed during execution and use it in some kind of syntax. So the way this happens in COBOL is it looks like this. You have the word function, and then the name of the function. And if it has parameters, some functions don't. There are at least two I can think of, current date and pi, which don't take parameters, but certainly min does. I can pass some parameters in and compute a minimum value there. The advantages of these intrinsic functions is they work correctly. That's always a big advantage. They're reusable and they're very efficient. They've been written with efficiency in mind. It's unlikely you're going to be able to do it any better yourself. So it makes sense to call these functions if you have these sorts of problems to solve. Also, they solve a variety of different problems for us. The pattern, again, is the word function, the function name, and a parameter list in parentheses. Here's a couple of examples. Function random, which returns a random number between 0 and 1. This is a seed. I can give it various seeds to get various sequences of random. These are pseudo-random numbers, of course. And what comes back to me is a number, and I can capture it with a compute statement. This is a numeric value. I capture it with a compute statement. Here's an alphanumeric function, reverse. I can give it a string. It gives me the reversed string, and I can capture what comes back by moving it to a variable. So there are 6 categories of intrinsic functions: mathematical, statistical, some date and time functions, some financial ones. I'm not going to look at those today, some character handling, and just some general functions. There are about 70 of these things. And if you should look into this just to read the list, if you're trying to learn intrinsic functions, the first thing you should do is just read down the list. What are the names of these functions? You'll know immediately what many of them do. And if you actually have to use them, then you can certainly start reading the manuals about it. To find these things, you can Google Enterprise COBOL Documentation Library. That's the best place to go. Choose the correct version of COBOL. Like, there's a variety of versions. And then what you want to look for is the COBOL language reference and the COBOL programming guide. Both of those are excellent. it's hard to find better language documentation than what you can find in these COBOL language reference and programming guides. The language reference basically defines what COBOL looks like and does. The programming guide gives you lots of advice on and examples of how to code these things. So I'll start with some tips for beginners. If you're just getting started, coming to this from a different language, or you're just starting out in COBOL, the first thing I would suggest is code the parameters without commas. Now that's my opinion at this point. So that you can put commas to separate the parameters here, but if you do that, you have to put spaces after each comma, which to my eye looks a little funny. So my strategy has always been to just separate the parameters with spaces. I think it looks good and it's easier for me to remember. If you're just starting this, your experienced programmers can cover your ears at this point, but if you're just starting this, the syntax rules for using intrinsic functions can seem a little confounding if you're just getting started, particularly if you've programmed in other languages. As an example, if you code display function max ABC, the compiler will reject that. If you're coming to this from Java or some other language, that probably looks like something that should work. It doesn't, because this function returns a numeric value, and display doesn't work well with numbers. It is capable of displaying strings and things like that. So this does work, right? This doesn't work, but this, which looks very close, does not. So using these things can sometimes be confounding. It takes a little experience to get used to where can I code these functions and how can I use them in various ways syntactically. So my initial advice to you is don't try to be too fancy, at least at first. Get a little experience under your belt and then start experimenting. So here's my tip. Try this. If you're calling a numeric function, use a compute to capture the result. In other words, fire off the function and capture it using a compute. That's for numbers. If you're working with alphanumeric numbers, move the data to capture it. So you'll do a move on this string that comes back to you to this variable. After you've captured them, then you can compose some fancier syntax to work with the results. That's my beginning advice to you. Let me close these things to get rid of this. All right, so that's my beginning advice. One of the reasons for using these functions is that they work well, and by well I mean great, with tables. That's one of the main reasons to go to intrinsic functions. If you have tables that you want to play with, if you want to sum up a table or find a minimum value in a table, or find the position of the minimum value in a table, or find the maximum value or the position of the maximum value. If you're doing statistical functions like mean, median, range, standard deviation, variance, any of those things, all of those functions work great with tables. So I created a little example here. I created a sequence of values called test values, and then I do a redefines to define it as a table or an array, right? T redefines test values. What is a T? Well, it's a row that occurs twice, and each row is an item that occurs 4 times. So I get a table that looks like this. 2 rows of 4. Once I've done that, I also have this table result thing, which is numeric edited, right? The actual items in the table are numeric in this case. So here's my examples. I can say function sum t, and then I use this magic word all, which is why this is so brilliant. If I code the word all, it's as if I had typed all of the subscripts myself and pass the parameters into this function. So by coding all on a 2-dimensional array, basically I'm asking it to sum the entire array. Well, that's brilliant. I don't have to code loops to get what I need out of this table. I don't have to worry about initialization problems. I don't have to worry about being one-off problems. If the table changes, I don't have to worry about the size throwing my results off, right? I can just write one line that sums up this table and I've got the result. That's the brilliant part of it. You can use it in other ways. For instance, if you have a 1 in the subscript, that would sum the first row, the blue row. This works with single dimensional tables up to whatever the maximum result is, 5 or 6, I forget what the maximum number of subscripts you can have, more than we'll ever need. So this is one place where intrinsic functions works brilliantly, and this is something you should know about. The rest of the things I'm picking are somewhat arbitrary. I've just tried to focus on a few of these functions to give you an idea and advise you to poke your nose into the manuals to investigate the details of the ones that you might be interested in. But I tried to pick some common features that COBOL programmers can use in a variety of business programs. One of the things you might have to do is to take a value like this, a user-defined value, or maybe the user typed a value on a kick screen, or somehow the user created what they thought was a number, and you're having to deal with it as a programmer. Well, I can't really deal with this to do arithmetic on it, so I have to do a conversion. So I'm either faced with having to parse this somehow, and that would be a significant parsing problem to extract the number out of this thing. But there is an intrinsic function that will do that for us, numval-c. The C, I think, stands for currency. In other words, this value they're giving me can have a pound sign or a dollar sign. Currency symbol can have decimal points, commas. And this value will extract the numeric value and save it. So this numval1 is actually a numeric field that has the equivalent number. Now I'm making this a little simpler than it actually is. There are other functions that you can use, test functions that go along with this, so that you can test these values you're passing to numval-c. In other words, everything that you throw at it isn't going to work. So you might want to do some testing on this field before you actually fire off this function. And I'm not showing you that. Again, check out the user manuals for that. But you get the idea. Another thing that programmers sometimes do is change coding encodings, right? So we can move from EBCD to ASCII or vice versa. The way this works is we're going to go through Unicode as the middle ground. So IBM has a data type called national in COBOL. It's actually Unicode, and the version of Unicode is UTF-16. It's 16 bits. And this Unicode or national data incorporates lots of different encodings, two of which are EBCDIC and ASCII. IBM describes encodings as code pages. So there's an EBCDIC code page, and IBM numbers them. So that 1140 here is the code page number for EBCDIC, and 819 is the code page number for ASCII. I need some EBCDIC input. I'll just create a little field, ABCD 1, 2, 3, 4, and I have a field for the output. I have a function for that. There is a national of function that will convert from here to here. And then there's a display of function that converts from here to here, right? So we'll go through two conversions. Now I'm doing what I just told you not to do, right? I'm firing off a function inside of a function. So, but I wanted to show you that that is possible. And in fact, this is a nice way to do this. So let's just briefly walk through it. If I fire off national of, I give it my input, and I input the code number as well to tell this function that this input is in EBCDIC. So what comes back to me here is national, in other words, Unicode. And then I'm giving the Unicode to this function, display of, and telling it that I want to convert it to ASCII. And that does it. I am following my advice here, so I'm firing off a function and saving it. Since it's a string function, I'm saving it to AO. And that's in ASCII. And I'm playing on an EBCDIC machine, so I can't really display it very well. So I do one more conversion, say, okay, convert it to hex, and let's see what it looks like in hex. So there's 3 different conversions you can do, and you can play with. And you can go pretty much from any encoding to any encoding that can be represented in Unicode 16. There's a few more sample. Again, this is kind of completely arbitrary in some sense, what functions I'm picking. I'm just picking some of the ones I commonly use or might choose. If you're working strictly in EBCDIC, these 2 are handy. I can pass in an integer and ask what character is that. So if I give it 241, it tells me, oh, that's a 1 in EBCDIC, a character 1. If I give it a number 107, it tells me, oh, it's a character comma in EBCDIC. And this is the inverse function. If you give it a character, it tells you what number it is in the EBCDIC encoding. So if you give it a space, it'll tell you 64. If you give it a letter, which is a hexadecimal C1, it tells you, oh, it's 193. These are some conversion functions for strings. If you have a string, you can convert to lowercase. You can convert to uppercase. You can reverse a string. You can take a string and say, convert it to all 0s and 1s and convert it to a bit string. That's cool. You can take a string and say, give me a version of it in hex. Or if you've already got it in hex, you can say, give it to me as a string, right? So you can put in a string of hex and get back the equivalent character representation. If you have a string, you can trim off the leading spaces or the trailing spaces or both. There's some date functions. There's lots of date functions. So you say, give me the current date. That has no parameters. Here's an interesting one, date of integer. You put in an integer and it tells you what date it corresponds to. All right. Jumpy finger on my mouse here. So you can put in a number here, and the number you put in is the number of days that have passed since December 31st, 1600 in the Gregorian calendar, and that'll tell you what date corresponds to that. Yeah, see, these days I'm having trouble remembering that it is Friday. So these types of date functions aren't all that interesting to me at this point, but businesses do need them and make heavy use of dates. There are lots of math intrinsic functions. I just picked 2, square root, absolute value. There's lots more. There's trig functions. And this is one place where there's a lot of overlap between the COBOL intrinsic functions and the functions that you could get in the language environment. Okay, so there's some functions we can get if we're working in COBOL, some intrinsic functions that are built in and work great. What if I want to write a function myself in Enterprise COBOL? Well, you can't. Enterprise COBOL doesn't currently support user-defined functions. But as Tom Ross told me just yesterday, there are plans to incorporate this in the future. So the language will change. There is a workaround, though, and the workaround I want to suggest is to write a nested program. It's not going to be a function, but it'll be pretty close. So it turns out programs, I'm not going to spend a lot of time on this because this is mostly about intrinsic functions, but it's often the case we would like to have a function. So I'm going to give you an alternative and let you play with it a little bit. So programs can live inside of other programs. If you start thinking like this, though, if you start putting programs inside of programs, you want to start thinking much smaller. If you talk to most COBOL programmers and mention the word program, they usually have in mind these behemoth programs that are quite large. But in this context, we want to start thinking of programs as being much smaller, more like paragraphs, or maybe a couple of paragraphs together. So I want to start thinking much smaller. Oops, let me back up slightly. If I start doing this, I can pass parameters. I can always pass a parameter into a program and get something out of it. If I do this, the code that I'm writing in these programs is encapsulated, and the data becomes local. Programs that are outside of mine can't touch my data. So now I get this idea of localization of data. Everything's not global anymore. Well, that can be good, right? If I've packaged my code in a program, I can reuse it easily because after I test it and make sure it works perfectly, I can reuse the program and never have to test that part of it again. So I can reuse it. It turns out calling a nested program is very efficient. It's like performing a paragraph. You don't have to take my word for this. You can look in the IBM manuals where they've tested this and describe it. And if you think about it, it makes sense that nested programs can be much more efficient than programs that are separately compiled. The COBOL compiler has all of the code available at the time the program is being compiled. All the code is together in one source module. And so the COBOL compiler can look at all of these little programs you're writing and make them work like paragraphs. But you get the advantage that you can now pass parameters in and get a value out. The data is no longer completely global. So if something goes wrong, I don't have to look through 100 pages of code to get it. I can look in a single program, which is more like a large paragraph. The last advantage I'm going to mention to this is younger programmers will immediately recognize this style of programming because that's the style they've grown up writing. Okay, so everything has a flip side. What's the flip side to nested programming? My programs might look a little different. They're going to be less COBOL-like. And I'm technically not writing a function. I'm writing a procedure, but if I have a procedure that passes A, B, and C could be variables that are used for input, and C is the value I'm passing back. So it sort of works like a function. Just to give you, I'm not going to go into much more detail, but just to give you an idea of what it might look like. If I'm writing a program, I would just start off normally. When I'm finished with my program, if I wanted a function, I could start another program. When I'm finished with it, I have to add one new line in program B. So there becomes these ending delimiters we have to add when you start nesting programs. That's the only difference, really. The rest of this looks like a normal COBOL program. So does this one. The only differences are these delimiters. After I create my first little function, sort of function, I can start another one. And I can end it here. When I get to the bottom, I have to have a delimiter for the whole thing. If you don't like looking at these programs inside of other programs, you can do it this way. You can copy your programs to copy libraries and start building your own libraries of functions and include them. And then your program looks completely like a regular COBOL program. So this is a style that I've sort of adopted for writing many programs. I've found it helpful because over time, my copy library has gotten so large that all I really have to do now is write a driver program that calls these programs in the right sequence. And that is a big advantage because all of this code I'm including, I don't have to test like I do if I'm copying and pasting. So this is just a suggestion. You can write something that looks sort of like a function this way. Now, I've got some sample programs for this available on my website. One's called Function Demo. I'll point out where these are in just a second. One's called Function Demo, and there's nothing special about this program. All it is it creates a little data and it fires off a few functions, and they're not related to each other. So if you just want something you can use to experiment with your own functions, you could use this particular program. If you're interested in this nested idea I mentioned at the end, you could grab this program, Stacky. I'm not putting this out as the best program style in the world. All it is kind of a proof of concept program. It allocates storage, creates a stack, reads a file, pushes the records on the stack. Technically, it's not pushing the records on the stack. What it's pushing are pointers to the records on the stack. And it pops them off in reverse order and prints them out in reverse order. This thing runs in version 6.3 because of this allocate verb. Allocate is a new verb that can dynamically allocate storage. and I print out the pointers, so I had to do a redefinition on the pointers to get them to print. So if you're interested in that at all, you might check out Stacky. So that's, let me see if I can get this back and go here. This is my...
Dr. Wilbright?
Yes.
A couple questions.
All right.
Can we take a couple of questions maybe? All right, cool.
Sure.
One is, can we write a light program and access through the linkage section?
Can we write a what kind of program?
Light program. Carl, can you clarify with a comment to your question, perhaps? That would help. Okay, and I think there was another question that Paul just shared here with us, and that is, okay, a light program as in a simple function. Can we write a simple function and access through the linkage section?
You can write a function, you can pass it some parameters, and it can have a side effect of returning a parameter. So yeah, you could write this minimum function we looked at, you could write that. It's not going to be as efficient as the intrinsic function that's built in, but you could provide that yourself as a net program. Sure.
Yep. Okay, yeah.
That's sort of what I tried to do.
Hope that answered your question, Carl.
I'll tell you what, I'll put another little program on the...
Yep.
I'll put another little program on this site. These two links down here are links to the sample code. I'll add another one that just does a very simple function, like min, or something similar. And I'll put it as a out here later today.
Oh, that would be awesome. Thank you so much.
Any other questions or?
Yes, Sudarshan, the other question
is there a reverse function?
Is there a reverse function?
Go ahead, Paul.
Oh, I'll go ahead and read it for you. Actually, oh, I'm sorry, that reverse function's a different one, but the one from the YouTube, it says, if I understood well, we can nest not only COBOL code, but for example, Java code too.
I don't think you can nest Java code. You can call Java, I think, from COBOL. The nesting of programs is for COBOL modules.
Okay, so hopefully that answered that. That came from the YouTube channel. And I'll go ahead, since I'm talking, I'll go ahead and the other question was out there. Is there the reverse function of integer dash of dash date? And then the person made reference to the manuals for date of integer and integer of date. So even myself, I'm not sure, but
I'm probably the worst. I'm probably the worst person to ask about date function.
Okay.
I usually don't know what it is, but honestly, I couldn't answer that question without looking at the manual.
Yeah, and I might suggest, Fernando, if it were me, I would actually experiment and find out what's the compiler capable of doing. You could always attempt it.
Right.
Good point. Yeah.
And I think that's all the questions I see.
Early on, there was another. Yeah, earlier on, there was one other. Will Dr. Wilbright explain parameters to include examples? And I think there were plenty of those that you shared, Dr. Wilbright, but I'll let you answer that.
Now, let's take a look at, we'll look at this program, Stacky. This is the COBOL code for it. It's just a regular COBOL type program. I think I'm passing parameters here. Let's see. Yeah. So here's Here's the push parameter. It has two subprograms. One's push and one's pop, pushing onto a stack and popping off of a stack. Right here, here's my procedure division where I'm using my stack. So I'm passing in a couple of parameters. Once I'm inside, if I change one of the parameters, it has a side effect in the calling program, right? So let's see if I can find my call. Here's a call. So I can say call pop using, here's the parameters I'm passing. And if I find pop, let's see, here's pop. I have a matching procedure division statement that matches up those parameters with the local names that I'm going to use. And those are names that are described in linkage. So I'm passing the parameters here. If I make a change in one of these parameters, it has a side effect back in the calling program. So I get the effect of a function. I can't use it syntactically like a function, but I get the effect of it. So there's an example of a nested program. It looks a little different if you're a COBOL programmer and running into another program down the pike here. But if you don't like that look, as I said before, you can instead put these programs, as you debug them, you can put them in a copy library and do includes on them. And then it looks more like standard COBOL. So there's an example of the nested programs. The other example was just intrinsic functions. So this is a program. There's nothing much to this. I created some data areas, some arrays, and then I just do a sequence of computes here. So I can do compute smallest equals function min. You can try to do it with commas like this one does, but that's not going to work because of the spacing. So you have to code it like this or like that. So we're just trying to give you a few examples of calling these intrinsic functions in various ways. Here's my random call. Initially, you give it a seed, and it gives you back a number between 0 and 1. Subsequent calls, if you want the next random number in a sequence, you would leave off the parameters, and it would give you kind of the next number that was started at this sequence that this seed generated. Here's an example where I'm passing in a single dimension array and summing it up. And so it's just a collection of random calls to functions. It doesn't do anything. There's no flow to this thing other than just a sequence of functions you can look at as examples. And it gives you a working program that you could play with if you want to try some of the functions from the manual. So those are the two sample programs I've given. The other links are here. This was the webcast slides from several weeks ago, and these are the slides. If you want to look at the slides today, you can get them here. The rest of this is a COBOL course I put together, video course I put together. So if you're interested in working through an entire course, you could check out the rest of this. And that's about all I've got today.
Awesome. So I just want to elaborate on the parameter question, Dr. Wilbright. Our participant has added to their question. So early on in the presentation, for instance, there was a page where you talked about some intrinsic function examples, and in parentheses, for instance, it said A, B, C, D kind of thing. I think what our participant is asking is it possible to show a couple of examples of, what the function is and exactly what the parameters are? So I think, is there a specific function with parameters that you could share?